Hello, good morning all. Now, today let us discuss the topic solution of differential equation using Laplace transform. So as you know, it is one of the most important applications of Laplace transform. That is, we can find out the solution of certain differential equation with the help of Laplace transform. So I am going to explain that. So first of all, we should study some results of Laplace transform. That means how we can find out the Laplace transform of certain derivatives of certain function. For example, so here first you have to learn the result that if y of t is a continuous function of t, then we can find out the Laplace transform of y dash t using a result. Laplace transform of y dash t equal to s into Laplace transform of y of t minus y of 0. That is the condition. Y of 0 is the initial value condition. Similarly, Laplace transform of the second derivative y2 dash t we can calculate it using another equation. That is, it is equal to s square into L of y of t minus s into y of 0 minus y dash of 0. One more derivatives. Suppose we have to find the third derivative, Laplace transform of the third derivative. Then Laplace transform of y triple dash t equal to s cube into Laplace transform of y of t minus s square into y of 0 minus s into y dash of 0 minus y2 dash of 0, and this results on. We can find out the Laplace transform of any derivatives of this function y. So first thing is, in this topic, first thing is you have to by heart this equation. How we can find out the Laplace transform of certain derivatives. Now our problem is we have to find out the solution of differential equation using this Laplace transform. Guys, we have already studied in our third module how to find the solution of certain differential equation using various methods. So here we are going to discuss another method to find the solution of differential equation by using Laplace transform. I will give you an example. You will be given a question like this. First question, using Laplace transform, solve the differential equation y dash plus 4y equal to t with the condition that y of 0 is equal to 1. Y of 0 is equal to 1. So, listen, we have given a differential equation. It is clearly a first order differential equation. Y dash means the first order. So, it is clearly a first order differential equation, and in addition to that, there will be given that one additional condition, y of 0 is equal to 1. So, in this section, our first step is apply Laplace transform on both sides of this equation. That means our equation is y dash plus 4y is equal to t. So we are going to apply Laplace transform of y dash plus 4 into Laplace transform of y is equal to Laplace transform of t. Y means y of t. Y is clearly it is y of t. Y is a function of t. Similarly, y dash means simply it will be a function of t. So y dash t. So we get first step is we have to apply Laplace transform on both sides of the equation, as we know that Laplace transform is linear. So by the properties of linearity property, we can split the equation as L of y dash plus 4 is a constant, 4 into L of y is equal to L of t. Now what is L of y dash? L of y dash t, we have L of y dash t equal to, we can find out it by using the equation S into L of y of t minus y0. So substitute the result for L of y dash. So L of y dash is S into L of y of t minus y of 0 plus 4 into L of y of t, y means y of t, is equal to L of t. What is Laplace transform of t? Laplace transform of t is 1 by s square, that we know. Now the second step is, next you have to replace this y of 0. We have already given the initial value condition y of 0. When t equal to 0, the value of y is equal to 1, that is given. So we can replace this y of 0 also. So s into Laplace transform of y of t minus 1 plus 4 into Laplace transform of y of t equal to 1 by s square. Now we can club these two terms. Both are Laplace transform of y of t terms. So club the terms, we get s plus 4 into Laplace transform of y of t minus 1 equal to 1 by s square. So s plus 4 into Laplace transform of y of t equal to 1 by s square plus 1. So L of y of t equal to, cross multiply this, we get 1 plus s square divided by s square into s plus 4. This s plus 4 will be here, 1 plus s square. So L of y of t equal to 1 plus s square by s square into x plus 4. So the next step is, from this we can write y of t. Therefore y of t equal to, so we get the answer as L of, not complete, L of y of t equal to 1 plus s square by s square into s plus 4. Therefore y of t can be find out the inverse from L inverse of 1 plus s square divided by s square into s plus 4. So to find out the inverse, to find out y of t, we have to find out the inverse of this 1 plus s square by s square into s plus 4. So how will you find out its inverse? We have already discussed in our previous classes. This is a function in which degree of the numerator is strictly less than degree of the denominator. What is the degree of the numerator? 2. Degree of the denominator is 3. So it is clearly strictly less than degree of the denominator. So we can apply the method of partial fraction. So consider this function 1 plus s square by s square into s plus 4. We can split this function as here. The factor s appears in 2 times. So with this we can write as a by s plus b by s square. Then next term is s plus 4. Let's linear factor is s plus 4. So that we can written as c by s plus 4. So we have to find out these constants a, b, c. So what is the step? We multiply throughout with this denominator 1. So LHS we get 1 plus s square is equal to a s into s plus 4. In the first term this s will cancel, the remaining term is s into s plus 4. Similarly in the second term s square will cancel, remaining term is s plus 4. Then in the third step c s square remains. Then we have to find out these constants a, b, c. The first step is put s is equal to 0 on both sides. Then we get, in the LHS we get 1 is equal to, if s is equal to 0, this term will be 0, then equal to 4b. First and third term will cancel. So 1 is equal to 4b. Therefore b is 1 by 4. We get b equal to 1 by 4. Then we can put s is equal to s plus 4 is a factor, so we can put s is equal to minus 4. Put s is equal to minus 4 on both sides of this equation. On both sides of the equation, same equation. So we get when s is equal to minus 4, 16 plus 1, 17 equal to the terms containing s plus 4 will cancel, only cs square remains. So when s is equal to minus 4, we get 16c. 16c. Therefore c equal to 17 by 16. Okay. Now we have to find out one more constant, that is a. Here a is the coefficient of s square. So equating both sides, equating coefficient of s square on both sides. Equating coefficient of s square on both sides. So here LHS coefficient of s square is 1, that is equal to, in the right side we can say that coefficient of s square is, one term is a and second term is the c. So a plus c, a plus c. Therefore this a equal to, we can write 1 minus 17 by 16. That is, we get it as minus 1 by 16. So we find out all the constants a, b, c. Therefore the function s square plus 1 by s square into s plus 4 can be written as a by s. The terms is a by s. So a is here minus 1 by 16. Minus 1 by 16 by s plus b by s square. B is here 1 by 4. B is 1 by 4. So 1 by 4 by s square. Then c. C is 17 by 16 by s plus 4. Now we can apply the inverse throughout this equation. Therefore L inverse of s square plus 1 by s square into s plus 4 equal to, here minus 1 by 16 is a constant that we can take on outside and apply the inverse for this function only. So L inverse of 1 by s plus 1 by 4 is a constant that we can take on outside and apply the inverse for function of s only. So 1 by s square, here 1 by s square remains. Then in the third term 17 by 16 is a constant and L inverse of 1 by s plus 4. So now minus 1 by 16. What is the inverse of 1 by s? Inverse of 1 by s is equal to, we all know that L of 1 is equal to 1 by s. So inverse of s 1. So into 1 plus 1 by 4 into L inverse of 1 by s square. So that we know L of t is 1 by s square. So inverse of 1 by s square is equal to t plus 17 by 16 into inverse of 1 by s plus 4. 1 by s plus a inverse is e raised to minus 80. So we get the answer as e raised to minus 40. So this is our answer. Y of t equal to, we have already write as y of t equal to, in the starting problem we already write as y of t equal to L inverse of 1 plus s square by s square into s plus 4, and we find the y of t as minus 1 by 16 plus t by 4 plus 17 by 16 into e raised to minus 4t. Clear? So these are the steps involved for finding the inverse. I will give you one more problem. Remember, our first step is we have to write the equation. Apply. First step, I will explain one more. First step is applies Laplace transform on both sides of the equation and substitute for L of y dash. Replace y of 0, the initial value conditions, and find out Laplace transform of y of t in terms of Laplace transform of y of t in terms of s. Then using inverse Laplace transform. Then by using inverse Laplace transform we can find out the original function, solution of the differential equation. Here solution is actually y of t. So using inverse Laplace transform we can find out this y of t. So next we are going to consider the inverse. So for that, first we write the equation 1 plus s square into s plus 4 as, by using method of partial fraction, we write it as a by s plus b by s square plus c by s plus 4 and find out the constant. Simply substitute and we get the final answer as minus 1 by 16 plus t by 4 plus 17 by 6 into e raised to minus 4t. I will give you one more problem, then only you can understand. So next, using Laplace transform, solve the differential equation y2 dash minus 3y dash plus 2y is equal to 4e raised to 2t, and we have given that y of 0 equal to minus 3 and y dash of 0 is equal to 5. So we have given a second order differential equation and also two conditions are given. This kind of equations are generally known as particular value solution, right? So our first step is apply Laplace transform on both sides of the equation. That is, here the differential equation is y2 dash minus 3y dash plus 2y equal to 4e raised to t. So we are going to apply Laplace transform. L of y2 dash minus 3 is a constant, L of y dash plus 2 into L of y is equal to 4 into L of e raised to 2t. Remember one thing, here y means it is a function of t. Similarly, simply y dash means it is a function of t. Clear? So now what is L of y dash? We have the results. L of y dash is equal to, yes, L of y dash is equal to, what is that? S square into L of y of t minus s into y of 0 minus y dash of 0. Now there is only one more derivative is there, L of y dash. So L of y dash is s into L of y of t minus y of 0, right? So substitute these two equations in this equation, put it as equation number 1. We can write this equation as equation number 1. Now you replace this L of y2 dash and L of y dash in equation 1. So instead of L of y2 dash we can write this equation, that is equation 1 becomes s square into L of y of t minus s into y of 0 minus y dash of 0 minus next term 3 L of y dash. So 3 is common. L of y dash, instead of L of y dash we can write s into L of y of t minus y of 0. Then next term is 2 into L of y plus 2 into L of y equal to 4 into Laplace transform of e raised to 2t. What is Laplace transform of e raised to 2t? That is 1 by s minus 2. 4 into 1 by s minus 2. Then next step, we have to replace this y of 0 and y dash of 0 from the given data. We have already given y of 0 equal to minus 3 and y dash of 0 is equal to 5. So we can easily replace these values here. So s square L of y of t minus s into y of 0. So plus 3s minus y dash of 0, that is minus 5 minus 3 into s into L of y of t minus y0 minus minus plus, it becomes plus 3 plus 2 into L of y of t is equal to 4 by s minus 2. Now you combine this L of y of t terms. There are three terms L of y of t. So we combine that equation, that is s square minus 3s plus 2 into L of y of t plus this 3s minus 5, then minus 3 into plus 3 minus 9. Minus 9 is equal to 4 by s minus 2. That is s square minus 3s plus 2 L of y of t equal to 4 by s minus 2. Then plus 3s becomes minus 3s when we shift into right side. Plus 3s becomes minus 3s. Here minus 14 is here. When we shifted to right side, then it becomes 14 plus 14. Clear? Therefore L of y of t equal to 4 by s minus 2 into s square minus 3s plus 2 minus 3s plus 14 divided by this term s square minus 3s plus 2. Therefore y of t using inverse. So here we have two terms in Laplace transform of y of t, that is 4 by s minus 2 into s square minus 3s plus 2 minus 3s plus 14 divided by, don't write here minus bracket here because minus is only for 3s. Minus 3s, write this minus 3s plus 14 by s square minus 3s plus 2. So using inverse method, inverse Laplace transform, we can find y of t. So y of t equal to L inverse of 4 by s minus 2 into, listen, what are the factors of s square minus 3 plus 2? That is s minus 1 into s minus. So s minus 2 occurs 2 times s minus 1. Clear? S square minus 3s plus 2 is equivalent to s minus 1 into s minus 2. Product is 2 and the sum is minus 3. Clear? So this we can write as, the first term we can write as 4 by s minus 2 whole square into s minus 1 plus L inverse of minus 3s plus 14 divided by, what is that, s minus 1 into s minus 2. S square minus 3s plus 2 we can write as s minus 1 into s minus 2. So put it as equation 2. There we can see two terms in this equation. So we can find out the inverse one by one. First you consider first we are going to consider the inverse of this term. First term, consider 4 by s minus 2 whole square into s minus 1. By the method of partial fraction, this we can write as a by s minus 2 plus b by s minus 2 square plus c by s minus 1. Clear? So we have to find out this constant a, b, c. So multiply throughout this constant, this product s minus 2 whole square into s minus 1. We get LHS 4 is equal to a into s minus 2 into s minus 1 plus b. In the second term s minus 2 whole square will cancel, only s minus 1 remains. In the third term s minus 1 will cancel, remain s minus 2 whole square occurs. Clear? So here we can see the roots as 2 and 1. So when we put s is equal to 2, we get 4 is equal to, these two terms will cancel. First and third term contain s minus 2. So first and third term will cancel. So 2 minus 1 is 1b. 1b. Therefore, b is equal to 4. Now put s is equal to 1. Put s is equal to 1. We get 4 is equal to, then the first and second term will cancel. 1 minus 2 minus 1, so 4 is equal to c also. So c equal to 4. Now we have to find out this constant a. A is the coefficient of s square, right? So we equate coefficient of s squared on both sides. So coefficient of s square is here. Here s square coefficient is 0 equal to a plus, here coefficient of s square is a and another one is c. So a plus c. So when c equal to 4, here we get a plus c equal to 0. So we get a as minus 4. Therefore, we obtain all the constants a, b, c. So L inverse of this 4 by s minus 2 whole square into s minus 1, we can write as L inverse of this a by s minus 2. A is minus 4. So minus 4 by s minus 2 plus L inverse of b. B, that is 4 by s minus 2 square plus third term L inverse of c. C is 4. 4 by s minus 1. Now this is equal to minus 4 constant. Inverse of 1 by s minus 2 is e raised to 2t. Then second term 4 is a constant. Inverse of 1 by s minus 2 whole square. That is, we know that L inverse of 1 by s square is t. So here instead of s we can see that s minus 2. That means t into, there is another function, that is e raised to 2t. Right. Then the last term 4 into s, 4 by s minus 1. 4 is a constant. Inverse of 1 by s minus 1 is e raised to t. So we get the inverse of first function. Listen, our problem y of t consists of two terms. Y of t equal to L inverse of this plus L inverse of another term. So next we are consider the second function. Okay. Now consider second function. Consider the second function, that is minus 3s plus 14 divided by s minus 1 into s minus 2. So this we can write as, clearly degree of the numerator is less than degree of the denominator. So this we can write as a by s1 plus b by s minus 2. Now multiplied with this product throughout, we get minus 3s plus 14 equal to a into s minus 2 plus b into s minus 1. So when we put s is equal, here 2 and 1 are the roots. So put s is equal to 2 on both sides. We get minus 3 into 2 minus 6 plus 14, that is 8 is equal to b. Then when we put s is equal to 1, s is equal to minus 3 plus 14, that is 11 is equal to, and minus 2 minus a. Minus a. So a is equal to minus 11. A is equal to minus 11. Therefore, thus our function is, what is our function? Minus 3s plus 14 by s minus 1 into s minus 2. We can write as minus 11 by s minus 1 plus, see, we have taken minus 3s plus 14 by s minus 1 into a by s minus 1 plus b by s minus 2. So here a is minus 1 and b equal to 8. So 8 by s minus 2. Therefore, inverse of minus 3s plus 14 by s minus 1 into s minus 2 equal to L inverse of minus 11 by S minus 1 first term plus inverse of second term 8 by S minus 2. That is minus 11 into e raised to t plus 8 into e raised to 2t. So we find out all these functions. We find out the inverse Laplace transform of both the function. Therefore y of t equal to equation 2 becomes y of t equal to, what is the first inverse we get? First term inverse is minus 4 e raised to 2t plus 4t into e raised to 2t plus 4 e raised to t. Then second we obtain as minus 11 e raised to t plus 8 e raised to 2t. Now adding the similar terms, minus 4 e raised to 2t plus 8 e raised to 2t. So 4 e raised to 2t. Next plus 4t e raised to 2t. 4 e raised to t minus 11 e raised to t. So 4 minus 11 minus 7 e raised to t. So which is the required answer? So we find the inverse of inverse Laplace transform of the given function, and y is the solution of the given question. Clear? I hope you can understand this. So please go through it and study well. Bye. Take care.